Hello, now we are going to solve a particular problem on AVL tree. Let us have a look. So, these are the elements and we are trying to construct one tree, that is AVL tree, which is self balanced binary search tree. Let us have a look. In the first phase 50 is inserted. So, step 1 is 1, I am just making as to understand, this is step 1. So, 50 is there. What is the balance factor for this? 0 minus 0, that is 0, no problem. Step 2, next we have 50 here, then we are going to insert 20. So, 20 will be left child. So, where we have inserted 20, we will calculate 0 minus 0, that is 0, balance factor. For 50, what is the balance factor? 1 minus 0, this is 1. Then 50, then 20, then 60. So, for 60, what is the balance factor? So, 0 minus 0, this is 0. For 50, 1 minus 1, it is 1, sorry, it is 0. For 20, 0 minus 0, it is 0. So, these are the balance factor values. Okay. So, where we will calculate from, so this is not required also, this is also not required. Okay. So, then we will go for our next, this is 50, then 20 is here, then 60 is here. For after 60, what is inserted? 10 is inserted. So, where the what element is inserted from that node to the root node of that particular tree. We will follow that path and calculate the balance factor. Where is the problem? We will just make the rotation. So, for this balance factor is 0, for this balance factor is 0 minus 1 minus 0, that is 1, for this 2 minus 0, 1, 2 minus 1, this is 1. Okay. So, for 60 it is not required, we will start from the newly inserted node, follow the path to reach the root, and in that path we will calculate the balance factor value, and this way we will continue. Then what? Then what element is there? 8 is there. Okay. Then we insert, then we will insert 8. Okay. So, 50 is here, 60 is here, 20 is here, 10 is here, and 8 is here. Now, look, for 8, what is the newly inserted node? 8. So, balance factor of 8 is 0, balance factor of 10 is 1 minus 0, that is 1. For this one, 2 minus 0, this is 2. So, the problem is here, for 20 the problem is arising here. So, what is the problem? How we will recognize? Will where the problem is, from that node to the newly inserted node, follow that path. This is left and left. So, this is called left imbalance. What is the rotation is required? We will rotate, we will make this element up and 20 will be down. So, we will rotate this one. So, what will be the next case? So, we will have 50 here. So, we will have 50 here, 60 this side, then we will have 10 will be up, 20 will be its right child, and 8 will be its left child. So, by this, if we observe the balance factor for all the nodes, it is okay. Okay. So, we know what are the 3 balance factor values which are applicable: 0, minus 1 or 1. Only these 3 values are allowed, other values are not accepted. Okay. So, this is the case, only one rotation is required. Then what element is inserted? What element is inserted? So, we will insert after 8, we have 15. Okay. We have 15 here. So, 15, 50 less than 50 greater than 10, this 15 is here. So, 15 is here. We will calculate the balance factor values. What are the balance factor values? For from 15, this is 0, 1 minus 0, this is 1. for this 1 minus 2, this is minus 1, for this 1, 2 and 3, 3 this side 1, that is minus 1, that is 2. So, problem is here, problem is at which node? Problem is at this node. We will follow the path towards the element which is newly inserted. This is left, this is right. So, this problem is called left right imbalance. So, for left right imbalance, there are two rotations are required to balance it. One is we will make the problem into LL imbalance and then we will go for another rotation. So, here we will go for first we will rotate. So, first 50 is here, then 60 is here, then what? So, what rotation is required? What is the rotation here? So, we will rotate from, so 20 will be up, 10 will be down, we will rotate this side. So, 20 will be up, 10 will be left child and 8 will be right child and 60 is here. Now, where we will place 15? So, look 15 is lesser than 20 and greater than 10. So, 15 will be here and also you will observe that 15 is the was connected, 15 was connected with 10 also by help of 20. So, 15 is here. So, this is one rotation, another rotation is required, another rotation is what? We will, the problem is here. So, we will make another rotation. So, first one, then this value, upper value. So, this value will be rotated. So, 50 will be down there, 20 will be up. So, 20 up, 50 is down here, 60 is here, then 10 is here, 8 and 15. Now, if you calculate by help of by help of two rotations, here one rotation, here another rotation, by help of two rotation, we have made the change. Okay. If you observe this, you will able to understand the very carefully. You will observe that the value all the nodes, the valence factor values are okay. If you are not sure, just calculate for this particular time. This is 0, this is 0, this is 0. This is for this node 1 2, this is 1 2, this is also 0, and for this is 0 minus 1, this is 0. So, have a look, all the balance factor values are okay, all the values are accepted. Now, what is the case? We will making it little bit smaller, so that I can able to draw in the same page. Okay. Have a look. Now, for this, after this, so this is the last case. For this, what is the case? This is 20, 50, 60, 10, 8, 15. Okay. Now, what is the element? 32. So, where 32 will be inserted? 32 is greater than 20, lesser than 50. So, 32 is here. So, 32 is here. So, for 32 balance factor value we will calculate 0. This is 1 minus 1, this is 0. For this is for this 2, this side also 2, this is also 0. So, no problem. So, always we will start calculating balance factor value where newly inserted node, from the newly inserted node to the follow the particular path till the root of the tree. No problem, 32 is inserted. Then what element is there? 46. So, if we insert 46, let me draw it again. So, 20 is here, 50 is here, 32, 60, here it is 10, here it is 8, here it is 15. Okay. Now, we are going to insert 46. We are going to insert 46. So, greater than 20, lesser than 50, greater than 32. So, 46 is here. So, we will start calculating the balance factor values. This is 0, 0 minus 1, this is minus 1. For this 2 minus 1, 2 minus 1, this is 1. For this 1, 2, 2 minus 1, 2, 3 height, that is minus 1. No problem. Still we have no problem. Okay. So, we are going to draw it again. So, 20, 50, 60, 32, 46 and this side it is 10, 8 and 15. Okay. Now, what is the new element? New element is 11. So, where it will be inserted? So, the new element will be inserted where? Lesser than 20, greater than 10, lesser than 15. So, this is 11, 11 is inserted here. Now, we will calculate the valence factor values. So, for 11 this is 0, for this 1 minus 0, for this is 1, for this 1 minus 2, 1 minus 2. So, this is minus 1, for this 1, 2, 3, okay, 1, 2, 3. Okay. So, this side 3 minus 1, 2, 3 height. So, or we can say the longest path also. Okay. This is also no problem. Now, what is the element? Last is 48. Now, tell me where we will insert 48. 40 will be inserted where? 48 will be inserted where? So, 20 greater than, lesser than 32, greater than 46, and 48 is here. Okay. So, if 48 is here, then we will check the valence factor values. This is 0, this is 0 minus 1, this is minus 1, 0 minus 2. So, this is minus 2. Okay. So, the problem is here, and it is right. So, it is right imbalance. So, for right imbalance, we will make a rotation, and that rotation is nothing but this element will be up and this will be down. So, the final tree will be 20, then left side there is no problem, 10, 8, 15, okay, 10, 8, 15, okay, right side it is 50, then 60 is its right, and this is 46 will be up, 32 will be down. So, 46 is up, 32 is down, and 48 is here. Now, if you observe, this is our final tree, this is our final tree, and it is balanced binary search tree or AVL tree. And always also remember that after rotation the final tree will be binary search tree. Okay, thank you.